Hey everyone, my name is Bretschneider, and today I'll be talking about Super Bowl commercials in the past, a time series analysis of them, and how much they've cost. So right now the year is 2013, let's pretend, and it's February. The Baltimore Ravens have just won the Super Bowl, and Dove has put a 30-second commercial in this year's Super Bowl, but they felt it was really overly expensive, and they're worried about meeting their budget for the rest of the year. So they want to look ahead to next year and determine how much a 30-second commercial is going to cost them and whether that will keep them under budget. So it appears that Dove has budgeted approximately $3.5 million for the next year's Super Bowl commercial, but the CFO has kindly agreed to move forward with it if it comes in under $3.75 million or less. Here's a list of the costs of Super Bowl advertisements over the past 46 years, dating all the way back to 1967. And here we'll look at the methods we'll apply for prediction today. So regression, seasonality, and smoothing. Starting with regression, unfortunately it won't be applicable in this situation. The regression equation is y equals 75,213.58x minus 673,509. And the fact that a regression equation projects negative values right off the bat with that negative intercept is not a good sign. It goes like that for the first 8 years, starting with 67. Let's look at why it won't work based on some error values, though. So starting with mean error, you've got a large positive and negative values for mean error. That means that the prediction is either undershooting or overshooting, so you want smaller values, but unfortunately what I got for these error values are that all but a few of them are in the hundreds of thousands or the millions, so that's not what you want, really. The mean absolute deviation, the idea is for the values to be low, again, but unfortunately the values I got range anywhere from 250,000 to over 600,000, so again, not really low. Moving on to mean absolute percent error, or MAPE, the values are considered good if they're under 10%, but 20 to 30% is also considered acceptable. Unfortunately, 28 out of the 46 years of data resulted in MAPE values greater than 30%, and a few of them came in even over 1,000% as well. Finally, looking at tracking signal, the models assume to be working correctly if tracking signal values fluctuate between 4 and -4, but there are only 11 years out of the 46 that had values that fell within this range, so that's really not going to work either. MAPE and tracking signal are really the most significant categories to look at for regression predictions. Unfortunately, there are only a few years of data in each category that fit within the desired ranges, so really regression is not going to work. And here you see why visually as well, because there's a regression trend line that doesn't really fit. It's linear and it doesn't really fit with the exponential trend of the actual data. So seasonality is a no-go as well, unfortunately. You kind of expected that going in because we're looking at yearly data rather than months or quarters. But I thought that perhaps the presence of the Olympics every 4 years could provide some seasonality. It would provide a bump in viewership for the Super Bowl if everyone was hyped on sports. But looking at calculated seasonal factors, everything was under 1, so none of those are really seasonal. Finally, something that might work is smoothing techniques. So you're looking at moving averages, weighted moving averages, and exponential smoothing values. The moving averages come in at 3-year, 6-year, and 10-year moving averages. Here on the graph, you see the red cost trend line. Sorry, not trend line, the cost line. But the 3-year moving average is the closest one accurately, and although the orange 10-year moving average line is the smoothest of those, you want the most accurate when you're making predictions, so I'm going to go with the 3-year moving average. Moving on to weighted moving averages, there's the 3-year, 6-year, and 10-year again. In parentheses there, you see the weights that start with the first year, most recently the first year, and then moving back in time from there. On the graph, the blue line is the cost here, and again you see the green 3-year weighted moving average line is closest to that accurate inaccuracy. The 10-year looks to be the smoothest again, but again you want to go with accuracy over smoothness most of the time, so 3 years is going to work there. And then exponential smoothing, there's the alpha value of 0.1 and the alpha value of 0.5. 0.1 is shown on the blue line, and then the green is the 0.5 value line that is the closest to the orange cost line. And although the blue is the most smooth out of the two, the green 0.5 line is definitely much more accurate. So we're going to look at 3-year moving average, 3-year weighted moving average, and exponential smoothing at 0.5. They're the 3 most accurate methods for prediction, and here are the values listed for predictions for 2014. The average of all 3 of those values is $3.51 million, so although it's slightly over the budget that we were hoping for, The advertising did come in under $3.75 million, so Dove should move forward with their commercial in 2014. Thanks.